All right, in this course, a lot of times we'll use some special angles quite a bit. Those angles being the 30 degree, 45, and 60 degree angle. The reason these are so important and why they're so special is they both can be, all three can be used in what we call special right triangles, things you probably looked at in geometry. There are two special right triangles, the 30, 60, 90 and a 45, 45, 90. The nice thing about these is they have the same ratio of sides no matter how big or small the triangle is. So in these triangles, in a 30, 60, 90, the sides are in ratio 1 to square root of 3. So the side across from the 30 is typically 1, across from the 60 is square root of 3, and across from the hypotenuse, or across from the 90, the hypotenuse is 2. Now you can multiply these all by some number and get the same ratios, but it all boils down to just these sides. For a 45, 45, 90 triangle, we call this an isosceles triangle. These two sides are the same because the angles across from them are the same, so we'll call these 1. And then the hypotenuse is the square root of 2. For both of these, you can verify that they obey the Pythagorean theorem, 1 squared plus 1 squared is square root of 2 squared, and etc. So what we're going to do is we're going to use these two triangles that I would highly encourage you to commit to memory to find the trig values of these three angles. Now the 45 degree angle we'll start with because it is typically the easiest. So in this chart, when I say take this box, sine theta of 45, we're really trying to figure out what is the sine value for a 45 degree angle. So for sine, if you recall for our SOHCAHTOA, sine is the opposite over the adjacent side. So we want to know what's the ratio of the opposite side to the hypotenuse for a 45, 45, 90 triangle. So if we think about this triangle over here, again, there's two 45 degree angles, so I'm just going to pick one. I'll say this is my angle. This is my theta. So this side will be my hypotenuse, this will be my opposite, and this will be my adjacent. So just like we always have before, we'll label the sides, and then we'll just do our ratios. So sine is opposite over adjacent, so that's 1 over the square root of 2. Cosine is adjacent over hypotenuse, that's also 1 over square root of 2. And tangent is opposite over adjacent, that's 1 over 1. These can also simplify. You can simplify this as radical 2 over 2. This is radical 2 over 2, and this is, of course, 1. So radical 2 over 2 is a very famous ratio in trigonometry. It's because it's the sine and cosine of 45 degrees. Now for the cosecant, secant, and cotangent, just like we did before, we can do some flipping. So if I flip the sine ratio, I get hypotenuse over opposite. It's just square root of 2 over 1, or just square root of 2. Because I'm just going ahead and I'm going back and flipping it from the original back here. You can flip it from there just as well as you can flip it from the end. So secant is also square root of 2. Cotangent, we're flipping tangent, so that's just 1. So that's all the trig ratios of a 45 degree angle. Now for a 30 degree angle, it's a little trickier. Because for a 30 degree angle, we have to figure out which side is opposite and adjacent. In the 45, it didn't really matter. So let's go ahead and do all the ones for 30. So if I'm doing 30, if this is my angle, if this is my theta, so I'm doing this first row here, then this side becomes opposite, and this side is adjacent, and this side is, of course, hypotenuse. When we do the 60, those will switch because the square root of 3 will become the opposite. But for now, we'll just go from here. So for the 30 degree, the sine of 30 is the opposite over hypotenuse, so that's 1/2. The cosine is adjacent over hypotenuse, so that's square root of 3 over 2. And the tangent is opposite over adjacent. Now, the only one that really needs rationalized is the tangent, so it's square root of 3 over 3 if I just multiply top and bottom by radical 3. Now for the last three, I can just start flipping. So I'll flip 1/2, which gives me 2. I'll flip radical 3 over 2, which is 2 over square root of 3, which rationalizes to 2 square root of 3 over 3 if I just multiply top and bottom by square root of 3. And then cotangent is just radical 3. And again, remember, you can flip from the original before you rationalize there. It just makes our life a little easier. Now for the 60, we're just going to switch things up. So if 60 is my angle, so if my angle is over there is 60, then now this becomes the opposite and this becomes the adjacent. So they'll switch. And this is still the hypotenuse, of course. But because they'll switch, you'll see, you'll get the same ratios. You get the exact same line as you do for the 30 degree. It'll just be in different spots. For example, the sine of 60 is the opposite over hypotenuse. So our new opposite is square root of 3 over 2. Which is what we got for cosine of 30. That's the same for sine of 60. And there is a pattern there that we'll see later on. The cosine of 60 is adjacent over hypotenuse. That's 1 over 2. The tangent of 60 is opposite over adjacent, so that's just square root of 3 over 1. The cosecant of 60 will go ahead and flip sine, so that's 2 over radical 3, which is 2 radical 3 over 3. The secant will flip cosine, and the cotangent will flip tangent, which simplifies to radical 3 over 3. So hopefully, and this is one of the big things in trig, you see all these patterns, like these two are related, and these two are related, and these two are related. So those actually form a very important set of identities in trigonometry that we'll talk about called cofunction identities later in the course. So just a quick kind of extension on how we use our trig ratios for these special triangles that I would highly suggest you commit to memory.